Okay, so the final video in our series of lessons on quadratics is a video on the discriminant. So by the end of this video, you will know what the discriminant is, and you'll be able to apply the discriminant to determine the nature of the roots of a quadratic. Okay, so you have already experienced the discriminant before. It is part of the quadratic formula, specifically the part of the quadratic formula under the square root sign. So the discriminant is b squared minus 4ac. And the reason why the discriminant is important is because of the fact that it's under the square root symbol. Okay, now we know already that you can't take the square root of a negative number, so if this became negative, it's going to tell us something very specific about our graph. If this number is 0, it's going to tell us something specific about our graph. And because we've already worked with examples where this is more than 0, you can see that you get two separate, distinct roots. So let's just take a look. So we have here, the discriminant is b squared minus 4ac, and we've got three graphs, one with two roots, one with one single root, and one with no roots. If b squared minus 4ac is greater than 0, then there are two real distinct roots. Okay, and if we take a look at this example here, we've got a distinct root here, and we've got a distinct root here. Now I don't know the equation for this off the top of my head, but if you were to know it and graph it, you would see that you do have those two distinct roots. Okay, then moving on to this second example. Okay, you have one root, it's also your turning point, and it happens right down here at -2. So then b squared minus 4ac is equal to 0. Okay, because you're only wanting one root. And then your last example, you can see here, you do not touch the x-axis anywhere, so you have no roots, no real roots. Okay, you have what we call complex roots, and that is something, if you were to look at complex roots, you would do if you were studying advanced higher or beyond. And then in that case, b squared minus 4ac is less than 0, and it's because we know that we can't take the square root of a negative number. So let's just look at some examples here. So determine the nature of the roots for y equals x squared plus 3x minus 7. So determining the nature of the roots means that we want b squared minus 4ac. My b value is 3, so I've got 3 squared. And then I've got 4 times the a value, which is 1, times the c value, which is -7. And we end up with 9, and then 4 times 1 is 4, times -7 is -28, 9 plus 28 because of the double negative, so then we end up with 37. So what we would say here is, since b squared minus 4ac is greater than 0, you can quite clearly see that it is in fact greater than 0, we have two real roots and they are distinct, and that means that they are different from each other. Okay, and having done this, if you wanted to, you could then go and find those two real roots because you have the quadratic there. Okay, but that's not necessary for determining the nature of the roots. Okay, so the next example, I'm going to change the colour of my pen, I'm going to go red this time. We have x squared minus 8x plus 16. So we've got b squared minus 4ac is equal to -8 squared minus 4 times 1 times 16. -8 squared is 64. 4 times 1 is 4 times 16 is 64. Minus 64, so we get 0. So when evaluating the statement and determining the nature, we can say since b squared minus 4ac equals 0, roots are real and equal. Okay, and this statement here, this evaluating statement that you put at the end, is the most important part of this calculation. So that is what the question is asking for. It's not asking you at the moment to calculate the discriminant, it's asking you to say, what are those roots like? Okay, and again, you can graph that and you'll see that you do get one root and it is on the x-axis. Okay, so let's look at the final example, and we'll change it to blue this time. We've got 2x squared plus 2x plus 9. So b squared minus 4ac is going to be 2 squared minus 4 times 2 times 9. So we would get 4 minus, and then 8 times 2 is 8, times that by 9 is 72. 4 minus 72 is negative 68. Okay, so we've come out with a negative discriminant, so we would say since b squared minus 4ac is less than 0, there are no real roots. And again, you can graph this and you can see clear as anything, it does not cross the x-axis, nor will it ever cross the x-axis. Okay, and that is how you determine the nature of roots using the discriminant. So let's just head back to the start and evaluate. So by the end of this video, you will know what this discriminant is. So it's here, plain as anything. The discriminant is b squared minus 4ac, and it is used to determine the nature of the roots of a quadratic. And we have 3 examples of doing so, one for each of the different spaces. So I feel like we've definitely covered that.